All right, it's top of the hour, so let's get started. Welcome, everyone. Thanks for joining us for another installment of Power Engineers Utility Network webinar series. So today we're going to show how utility network data can be extracted to support WindMil, but just as important, we're going to show how ArcGIS Pro improves the quality of GIS extracts and really can significantly reduce the time and effort required to get an accurate connected model that's usable within WindMil. Before we start, just a reminder that all attendees of this webinar, you're going to be in listen-only mode. But if you have questions as we're going through, we really encourage you to submit those questions using the Q&A box that's in the lower right-hand corner of the screen. So we scheduled some time at the end to answer your questions, so please submit those questions when you can. And finally, this webinar is being recorded, and we're going to provide you with a link to the recording in case you want to share that with others on your team who couldn't attend today. Now, let me introduce today's presenters. My name is Chris Erpelding, and I'll be moderating today's webinar. I'm the Consulting Department Manager for Power's Geospatial and Asset Management Business Unit, and I've been working in the GIS and utility industry for about 34 years. Now, Len Jewell and Robert Kreischer, they're going to be providing you with the majority of the webinar content and demonstrations today, and I really think you're in for a great treat with these guys. Len's a professional engineer and a solution architect, and he has over 25 years of experience. And prior to joining Power, he worked at Dakota Electric Association for about 12 years. And while he was there, he was a key driver for implementing a fully integrated Esri solution that includes an interface to Milsoft WindMil plus many other systems. Robert is a utility network guru, and he has over 12 years of experience in the industry. And if you're interested in finding out more about ArcGIS Pro and the utility network, he's written a ton of really helpful articles and blog posts, so check those out on LinkedIn and Power's website. Yeah, we're also pleased to have Remy Myers join us today as a special guest. Remy is Esri's product manager for the ArcGIS utility network. He has over 20 years of experience using GIS for land management, transportation, public health, and utilities, and he's a graduate of the University of Georgia with a master's degree in geography. We really appreciate all the support that Esri provides to their partners, and Remy is a really big part of that partnership. Before we get to Remy's opening comments, I want to just give you a brief overview of Power Engineers for those of you that don't know us. Power got started way back in 1976 by two electrical engineers and their dogs. That was in Pocatello, Idaho, and since then we've grown to over 2,600 employees in 50 states throughout the US and Canada. The company is divided into a number of divisions that are shown on the right-hand side of this slide. I know that a lot of attendees for this webinar are probably interested in the engineering topic, so I'll just briefly highlight the Power Delivery division that's shown at the top. The Power Delivery is by far our largest division, and they cover a full spectrum of engineering services, including distribution design, substation design and automation, distributed energy resources, or DER, advanced distribution management systems, or ADMS, energy storage, power testing and energization, cybersecurity, and really many other areas. It's really a super strong engineering team. And then our Geospatial and Asset Management division, which Len, Robert, and I represent, that's in the lower left corner. We cover all aspects of GIS and asset management projects from the initial planning all the way through deployment, training, and ongoing support. And we've got a really senior staff. We average over 20 years of experience. We're an Esri Gold partner, and we were the first group of companies, to achieve the utility network specialty. And we also received a special award from Esri for being the first to help an electric utility get fully into production with the utility network. And although 80% of our work, as mentioned on this slide, is focused on electric projects, I want to make sure to mention that we also do quite a few projects on gas, water, wastewater, and fiber. And obviously today we're going to be focused on showcasing an electric solution with the utility network and WindMil. But if you're from an organization that manages more than just electric assets, we have other webinars that are planned for later this year that cover other commodities. So once again, thanks for joining us today, and I really hope that you enjoy this webinar. So with that, let's get it kicked off with Remy Myers from Esri.
Hey, thanks, Chris. I really appreciate the opportunity to be here today. I've had the opportunity to work with Power Engineers for almost 20 years now, in my former life with Southern Company. And, I've always been impressed with the engineering and focus and drive behind all of the user-driven solutions that you provided for us, and now that we collaborate on. The utility network sits as that foundation as we continue to build user-focused solutions, whether it's across core drivers such as safety, reliability, customer service, asset management, or even innovation. That foundation of the utility network really lets us open up opportunities from a return on investment perspective and increasing utility partners, engineers, field workers to all collaborate and coordinate at a much deeper level than we've ever been able to do before. Slide, please. So looking at these core drivers, you can see that we've now got a wide range of options and solutions to address these performance tools and address these information management systems. And whether it's runtime or web or the desktop stack, you've got the ability to configure in a rapid and timely manner more efficient information solutions and systems than you've ever been able to do before. But what's really exciting for me is now the ability to collaborate and coordinate across traditional information systems that used to be siloed, such as operations or asset management or business development. Slide, please. So if we look at these solutions, they're not so much arrayed in a wheel. They're almost a constellation of applications that can all be integrated with each other. Traditional safety tools could work in conjunction with tools that are designed for your customer service team, or innovative solutions such as drones or IoT gathering platforms could certainly improve and help your grid modernization system. It's really exciting for me to see the progress that Power Engineers has done, not only with the foundation of the utility network, but building that integration out to information systems such as Milsoft. So with that, Lynn, go ahead and take it away, sir.
All right, thanks, Remy. Power is also really excited about the utility network, and we have invested thousands of hours over the past 3 years developing tools to help our clients migrate to the utility network. We have talked to a lot of utilities about their migration plans, and we consistently hear, hey, we can't upgrade to the utility network because there isn't a readily available way to create a windmill model from the utility network. Well, given our experience with the utility network, we knew we could address that, but we were also wondering if we could leverage the new Esri tools to make the current process even better. So we worked with a few clients to help us identify the major pain points, and we found it takes too long to get a usable model from the GIS extract. Extract often have many disconnected elements. The phasing is not right. The equipment database names in the extract don't always line up. Even after importing, it still takes a lot of time to enter settings and source information. And we need an easier way to incorporate meter data into the models. Well, we haven't addressed all of these yet. We have created a toolbox that will get the job done, and more bells and whistles to improve productivity are planned. We have developed what we are calling the Power Network Extractor Toolbox that will create the necessary windmill files from the utility network. There are two main tools in the toolbox right now. The first is the utility network extractor, and the second is the Milsoft processor. The two work together to produce the desired output. In the future, we plan on adding additional processors to handle other extracts like synergy and support for various ADMS systems. There are two modes for creating extracts. The first is an interactive geoprocessing tool as shown here. In this mode, the user first selects the utility network and tier, then the extent of the extract is chosen. Single circuits, substations, or the entire system can be selected for the extract. The user then selects the desired directory for the output files, followed by the Excel file that contains the mapping settings for the extract as shown here. Finally, the user clicks run, and it takes about 2 minutes to extract a circuit. In the interest of time, I won't perform an interactive extract for you during this webinar, but instead we'll take advantage of the second mode, scheduled. In the scheduled mode, the tool takes advantage of the out-of-the-box utility network functionality that tracks circuits that have been edited and exports the corresponding files on a schedule determined by the utility. In this mode, there is no waiting for an extract. The user simply navigates to the output directory and can immediately start working with the latest circuit information. As I said, the tool leverages built-in functionality of the utility network in ArcGIS Pro, including improved quality assurance tools that Robert will demonstrate shortly, and improved connectivity model. The utility network is quite robust and configurable. Definitely not a one-size-fits-all. It is up to each utility to determine the level of detail to include in their utility network model. Some utilities opt for a model very similar to the existing GIS model. We call this a low-fidelity model, while other utilities decide to enhance their model and capture additional details and information, resulting in a high-fidelity model. No matter what level of detail a utility decides to capture in their utility network model, the Power Network Extractor can use that model to create the required WindMil files. Before we import some extracts, let's take a closer look at what a typical overhead three-phase transformer installation looks like in both a low and a high fidelity network model. As previously indicated, a low fidelity utility network model often looks very much like the current GIS model. First, we have the primary and secondary lines, often geometrically connected. Then we would have the transformer bank modeled as a transformer electric device feature, and then the transformers themselves modeled as related unit records. This combination results in a completely valid utility network model similar to what has been used by utilities for years and fully compatible with the Power Network Extractor. Now let's look at a high fidelity representation. Remember that one of the goals of a high fidelity model is to capture greater detail about the assets and their relationships. Again, we have the primary and secondary lines, only this time they are not necessarily connected geometrically. The bank itself is typically modeled as an assembly that contains all of the other assets. Note that assemblies are not part of the utility network, but are associated with devices that are. The transformers themselves are now represented by transformer device features and are visible in GIS, as are any additional assets like the fuses shown here. Connectivity elements within the utility network are then used to connect the devices within the bank. The connection to the primary is shown as an electric junction. Similarly, the secondary connection. So rest assured that no matter which model a utility uses, the output from the Power Network Extractor will result in a WindMil device as expected. While it looks like a lot more work to maintain a high fidelity network model, in reality, Esri has provided a number of tools to make this easier. Plus, there are significant advantages of utilizing a high fidelity model. A high fidelity model can include substations and their components, which means GIS can be used to store WindMil source information. A high fidelity model also allows for additional asset information capture, as we've shown previously. A high fidelity model can provide detailed transformer configuration diagrams directly within GIS. And a high fidelity model can be used to capture individual equipment settings, like for regulators and protective devices. I'm going to do two demonstrations. In the first demonstrations, we will add a circuit to the existing model, examine overall connectivity, review some Milsoft equipment settings, and demonstrate the operation of the tie switch. In the second demonstration, I'll show an import of an extract from a high fidelity model where the assets are modeled as electric assemblies which contain the network devices, similar to the switch representation shown here. Let's take a look. So here I've got a low fidelity model and that I've already imported one circuit into, and I'm going to import a second circuit. Select import, use the default settings. I'm going to navigate to where the scheduled extractor has put my files. So, and I want circuit 5. I'm going to bring circuit 5 in. Circuit 5 came in, no warnings. Zoom to the extent. It's like, okay, I got my 2 circuits. Notice they're already pre-colored. That's set up in the extract configuration file automatically for you. Let's zoom in here a little bit where these 2 circuits are joined together. Take a look at this conductor, and I did get my Milsoft equipment information is here. Let's take a look at the transformer. Similar with the transformer. So far, looking pretty good. And now let me just take a look at this tie switch down here, make sure these are operational. I'm going to open this. This is now a disconnected element as I expected. And I'm going to close this in, and now becomes part of that circuit 5. So things are looking good. I'm ready to load my control point data in and my customer load data and get to work. I'm done, no messing around with connectivity, and I'm ready to go. So let's take a look at a high fidelity model. Only this time, let's create a high fidelity model from scratch. So we'll go in here and navigate to where I want my model. I'll give my model a name, Wi-Fi. I'm ready for my model. Again, I'm going to go import my model. And I'm going to leverage the fact that, hey, the extractor has already put my extracts out here. I just got to go grab them. Grab circuit 1315. Let's see what circuit 15 looks like. Bring it in. Again, no warning. Check. Everything looks like it's all connected. I like that. And I'm going to just zoom in. I've got switch elements down here. And let me just test a quick switch element down here. Opens up, it behaves the way I'd expect. I think I got a full connected model, with my, tied to my equipment settings, and I'm ready to bring in my load control point information and load data and actually start engineering. The power network extractor can extract circuits from both a low and high fidelity utility network and create valid WIN files for use. From Robert, utility network and ArcGIS Pro work together to improve the quality of the GIS data and reduce the time required to get a working engineering model. So, Robert.
Thanks, Len. So, as Len just showed us, we're now able to use Milsoft and the utility network in conjunction to do this analysis. What I'm going to go is I'm going to show you the other side of that equation. So, I'm going to show you how the utility network model and the tools built into it and ArcGIS Pro will help us keep that model in good shape. So to do this, I'd like to think of the old adage, a stitch in time. So a stitch in time saves later 9. And there was a really good conversation that I had several years ago with Larry Young. So when we first started doing the utility network and started working with customers or bringing them over into this model, we noticed that we were getting a lot of errors that were being reported by the system. And I brought this up to Larry Young at TOConnects, and he very boldly said this statement: "You are no longer allowed to have bad data." Once I was unpicking my job off the floor, we had a very insightful conversation that followed about what really was this bad data that we were seeing and what was the cause of it. And we ended up coming to a pretty good consensus that a lot of this was bad data that was actually in the source data and that it shouldn't be there. And the cause of this data tends to fall into one of 2 categories. So the first is process-driven. So validation and quality assurance in the current model is process-driven. It is optional, and there's no good out-of-the-box way of doing it. Now, there are extensions and tools that Esri provides that you can acquire, but a lot of utilities aren't necessarily implementing these. And there's also custom solutions you can buy that will enforce validation. But again, these haven't been consistently applied across the industry. On top of that, the validation frameworks provided by Esri really are providing errors as a message format in really a supervisory capacity. That is to say, they are not preventing you from making edits. They're not preventing you from going about your business. They're merely reporting to you items that they're finding. Depending on the tools that you're using to capture these messages, many times these values aren't necessarily being persisted in the database, so you don't have a record of these errors if they're not fixed. In addition to that, there's not necessarily, many of these solutions don't provide any accountability. In other words, there's no way for you to tell whether any given feature has been validated, what validation checks have been performed against it, or when it even last was validated. So to look at the impacts of this, let's take a look at what happens in a very common ArcMap and Milsoft workflow. So the GIS editor will be in the GIS making edits. They'll be doing as-built, they'll be doing designs, and they'll be going about their business. At some point, the engineer is going to want to take an extract from the GIS and import it into their Milsoft model. Now, when that happens, it's quite common for them to experience warnings during the import process. So they have to take these warnings from their import process, walk them over to the GIS department, give them a report, and then that GIS person is then responsible for making and incorporating edits to fix those warnings. After several iterations of this, typically the warnings will be brought down to an acceptable level, hopefully none, but usually not. Once that's happened, then the engineer can then import the model and begin validating it. As Len mentioned, that even after the model imports without warnings, it's still not uncommon for there to be disconnected elements or phasing problems present in the model. So what we want to do is we want to look at how ArcGIS Pro addresses this problem. And to put it briefly, they address it by incorporating all of the same sorts of checks and validations that you're doing in your Milsoft import into the core editing process. So let's walk through and look at what this process looks like. When I edit in the GIS, every feature that I'm created comes in as a dirty feature. So this is a feature that exists in the database, but has no network connectivity involved in it at all. In order for me to get it connected into the utility network, I need to run the validate topology tool. Now, when I do this, it's going to check those features that I've created and all of their relationships against thousands of rules that we and Esri have baked into the model to make sure that the features that you're connecting are valid. Now, if I've made a mistake and I've connected things that shouldn't be connected to each other, Esri will report out an error to me in the GIS editing environment, notifying me that I violated one of these rules, and this will allow me to immediately correct the error, rerun validation, so that I have now connected that feature into the network. Now, this is where the second level of validation comes in. Once I've connected features into my network, the next thing that it's going to do is it's going to make sure that those features on that network are properly participating within it. So what this will do is this will mark any networks that have been modified by my edits as being dirty. And then Esri provides a tool that will go through and it will check that circuit for things like de-energized features, phasing issues, loops, or even multi-fed circuits. So I run the update subnetwork tool, and if I've violated one of those constraints, they will again create errors for me immediately in the application. These errors are in the map, they're persisted in the database, timestamped. If I leave the application and come back, they're still going to be there waiting for me because I have to fix them. Now, once I fix them, I'm going to have a clean bill of health on that circuit, and that circuit will indicate to me that it is no longer dirty, that it is ready to be analyzed and exported. However, if I look at those features and I have business rules that I've defined against them, in our case, we're looking at business rules specifically related to Milsoft, I'll be able to see that those features have business rules that need to be evaluated against them. Now, I can go through and validate them, and as long as I've met all of the criteria for those business rules, I will then see that those features are valid, they meet my requirements, and I'm good to go. However, it is possible that throughout this process, I may violate one of these business rules. In that case, I will actually see a feature appear on the map with a validation error. I will be able to review the rules that have been violated, what their severities are. If they're high priority errors, like Milsoft errors, then what I'm going to do is I'm going to immediately resolve those, revalidate, and see that I'm in the clear. If, however, there are downstream systems that do merit having an exception, I can actually create an exception for those features, and the system will record that there is an error with this feature, but that it has an exception that has been granted for it, who did it, when they did it, why they did it. So with that being said, what I want to do is I want to demonstrate this process for you in a live utility network environment. Now, while I am showing these steps happening in this order, the business rules can actually be evaluated at any point throughout this process, which is something that you'll see. So why don't I bring up ArcGIS Pro here? So what we're looking at here is a utility network model for an electric distribution customer that we have. What you're seeing is essentially a circuit map where each one of these lines represents the three-phase backbone of a circuit. And in fact, they've been color-coded by their circuit names. So what I see here in this blue box is a dirty area. That indicates to me that this circuit or this area has edits that need to be validated. So all I do is I click this button, and Esri will go out and they will validate the topology in my current extent for all of those dirty areas. So while it's doing this, as I said, it's evaluating thousands of rules to make sure that everything I'm doing is correctly. Now, I have received a red dot, and there's going to be red lines in here. That means, also if you saw it in that notification there, that there are errors present in this area. So these red lines and points mean that I have point errors and line errors. I have violated rules in the network. So if I look at my display, me being familiar with my topology, I can tell that I have a pad-mounted transformer here, and somehow my user has placed a overhead transformer device inside that assembly. That is strictly not allowed, and the system has informed me of that. So to resolve this error, I simply come in, I mark this as being a pad-mounted transformer, I click validate, it will go through, it will make sure that everything that I have said is good, and it will give me a clean bill of health, now letting me know that all of the connectivity in this area is good. I will also do a quick check right now. As Len mentioned, this is a high fidelity model, and we can see that the primary and secondary lines are not actually connected physically. However, I can click this button, and the system will draw me lines showing that the high side of this transformer is connected to the medium voltage system, and the low side of this transformer is connected to the low voltage system. So the next thing I'm going to do is I'm going to turn on some of my validation layers, and I'll be able to see that this feature needs to be validated. I could run some other checks first, but I figure while I'm here, I might as well ensure that I'm meeting my business rules. So I open up Esri's Error Inspector, and similar to validation, I click a button, it will go, and it will evaluate all of my business rules against the area in my map. In this case, I can see I have a Milsoft Equipment ID error. If I look, I can see that it's telling me that my Milsoft Equipment ID isn't populated on this feature. Well, that's certainly not good, and I should go through and populate that. However, before I do that, I should let you know that this is one of the places where Power has extended the model to improve the user experience. Many extractors rely on the extract process to provide some sort of lookup value to calculate some equipment ID value for your features. What we have done is we have actually built that into the utility network model so that based off of the type of feature that I have and its compatible unit, I can tell you what piece of equipment is associated with it. Additionally, if I pick any piece of equipment over here, it will actually tell me the compatible unit that corresponds to it. This is a good way of making sure that all three fields, my asset type, my compatible unit, and my Milsoft description are all in agreement. So in this case, I'll say that this is a 100 kVA pad-mounted transformer. It's now letting me know that this is not a valid combination of values and that I need to pick a compatible unit in order for this to be correct. So I do. It gives me the only compatible unit that's associated with that piece of equipment. I can then reevaluate my rules, and I'm good to go. So next, what I want to do is I want to take a look at updating my subnetwork. If I turn on an error layer that I have that shows me phasing issues, I can see that I've got problems here. Now, just to make sure that these are all still issues, I'm going to go ahead and I'm going to trace my network. I can see that this circuit is dirty. I'm going to update it to see if maybe some of the edits I've made have cleared that phasing error. So while it's doing this, it's going through, it is checking the phasing, it's looking for multi-fed circuits, it's also checking for loops, And while it's doing that, it's also populating feeder IDs and energized phases on all of the features in my network. So if I zoom in a little bit, I'll see that I have detected a phasing issue on my network. These red lines are actually de-energized, and this blue line are places where I have dropped one or more phases from my network. Now, if I zoom into this area where it seems to be originating from, I can see this B phase line is energized, but this A phase line is de-energized. So if I zoom back out again, I'll see that it all originates at this same transformer I was looking at before. So what I can do is, if I look, I have an A phase line here, an A phase line here, but it appears that the bus of my transformer was set to be B phase. Well, that's just no good. So I'm going to go ahead and correct that to be A phase. Because the phasing is actually a network attribute, I do need to go back and revalidate my topology to make sure that everything is good here. Clean bill of health. Zoom out. This network is now marked as dirty again because I've edited features that participate in that network. I click Update Subnetwork. It's going to go through. It's going to retrace out the circuit, recalculate phasing, and it's going to pick up all of those features that were previously de-energized, populate the correct phasing on them, and populate that feeder ID on them. So once this comes back, which it should be doing momentarily, we'll see that the dirty flag on this network has been cleared. And this is really important because Len mentioned we have an automated process that goes through that'll extract circuits. And what that's actually doing is it's looking for circuits that have been updated but that have not been extracted. There's actually a flag that the system has that keeps track of when we've last extracted our Milsoft data. And when I run this tool, it will actually populate that flag, indicating to the system that we have actually confirmed and extracted this to another system. So this is the tool here. I would click run. It would do it. For the interest of time, I'm not going to run it right now. But as we can see, as Len was doing his demo, I did run this. In this case, this circuit was able to be extracted and processed in 46 seconds. All right. Coming back to the slides. So what I just showed you was how we can use editing within ArcGIS Pro to identify and resolve some of the most common Milsoft errors that we have before we leave the GIS. So I can make sure that when my as-built are happening and my designs are happening, they're doing it right the first time so that we don't need to come back to the GIS after the fact to correct issues for Milsoft. That being said, I'm going to hand it off to Chris, who's going to talk about what our next steps are. Chris?
All right. Hey, thanks, Robert. That was really a great way to show how some of those new capabilities in ArcGIS Pro really can benefit a WindMil solution. So the core of the webinar is what you just saw. But before we get to the questions, I wanted to just share a few thoughts and some recommendations for moving forward. As the next slide indicates, my main recommendation is if you haven't already done it, we recommend to get started down this road towards the utility network. As you've probably heard, the upgrade path for the new functionality, it's longer and it's more involved than other Esri upgrades. So it's important in our mind to at least get started on planning out your roadmap, because you're going to need to see what's going to be required in terms of time and resources down the road. And hopefully the benefits that Len and Robert outlined today for the Milsoft integration, WindMil integration, those are pretty clear. But of course, there's many more benefits that can help justify getting started. I'd like to take another look at that great slide that Remy showed earlier to just quickly re-emphasize some of the benefits. If you're interested in safety, and really who isn't, I highly recommend taking a look at Esri's recent business continuity webinars. And those showed how you can keep field crews and customers safe in the midst of the current pandemic using out-of-the-box Esri tools. If you're interested in improving customer satisfaction, take a look at some of the demonstrations that show how easy it is to create really compelling customer engagement portals, service request websites, really many other web-based apps with rich GIS content. If you're interested in the health of your assets and the reliability of your network, you'll love the increased granularity and accuracy of your data and the ability to tightly integrate asset management functionality. If you started a grid modernization project already, or if your organization is thinking about it for the future, this higher fidelity data that we've talked about today and the improved data quality, that's really going to make your life a lot easier. So that's good news. And finally, how many of you are looking into remote sensors, IoT, or machine learning? But we're seeing tons of activity in these areas with the utilities that we're working with. And the new utility network model is much more flexible than your traditional data model, and that makes it easier than ever to accommodate the new types of equipment and sensors that are really at the heart of innovation for utilities. These are just a few of the areas and benefits for utilities. Bottom line, there's a strong business case to be made for moving forward. So if your organization has already headed down that path, and I know that a number of you on this call already are, way to go, that's awesome. But for those of you who haven't gotten started yet, I know that taking that first step is often the hardest. Getting off the dime can be hard because, let's face it, it's human nature to be worried about change. We talk with organizations every week who want to get started, but they've encountered roadblocks of different types. Usually there's some system stakeholders within the organization that are resistant to change, and that's pretty normal. I found that the best approach is often just to take some small baby steps. For example, a small proof of concept that can help build confidence and gain internal support before you start taking some bigger steps. If you haven't started already, my next slide outlines just a couple of approaches that you probably could consider. These have worked really well for our clients, so I just wanted to pass them along. If your organization is pretty nimble and allows you to do small proof of concept projects, option one might be good for you. It's pretty simple. We hold a data standards workshop to determine some preliminary data mappings from your current system to the new utility network. We convert your data. We clean up as much as we can using our automated cleanup tools. We provide a data health check assessment. We give you some training and turn you loose to look at the new functionality with your actual utility network. And that uses a file database, so it's a very, very low barrier to entry. Option two is used for organizations that prefer a bit more planning up front. We create strategic roadmaps to give organizations the big picture. That helps them move forward with confidence. The strategic plan provides an overall game plan. It prioritizes the required tasks so you can get the best bang for your buck as you implement the new system in a phased manner. I found that these are super effective if you need to get executive support within your organization. We know what it takes to go from start to finish on these projects. Plus, we're an engineering company at our core, so we really understand the intricacies and nuances of the utility business. So, if you're interested in having Power help you get started on any of these items, I've included my contact information on the next page, and I'd love to talk with you whenever you're ready to get started moving forward. So we have a few minutes here left in our 45-minute time slot, so I thought we'd take a look at some of the questions that have come in thus far. And just a note, because I see some questions that are coming in here, if we run out of time and we can't answer all the questions, we'll definitely include written responses when we post the recording of the webinar. So the first question that I see is, what's the quickest way to get up and running on the utility network? Yeah, we talked a little bit about the initial steps, but I'm thinking that this question is looking for a little deeper insight. So I guess, Robert, this sounds like a good one for you to do. Do you want to chime in on this one about the quickest way to get up and running on the utility network?
Yeah, so the quickest way to get up and running on the utility network is really that option one that you called out in your slide, Chris. So one of the things that was a barrier to entry in previous releases of the utility network is that it required having all this new software and infrastructure installed in order to really even look at the data. The great news is in the ArcGIS Pro 2.5 release, they introduced the ability to actually run a utility network entirely standalone on a file geodatabase. We've worked with numerous customers on this, and we found that it allows us to get up and running in a matter of weeks with data sets. I think one of the second questions we had, the tools that we showed to do all of this validation, are these out-of-the-box tools or custom tools? So the Power Network Extractor that we showed is a tool that was developed by Power, but everything else that I showed you with all of the validation and rules and topology, all of that was out-of-the-box ESRI functionality.
Okay, great. Yeah, thanks, Robert. Did we get the question on what changes have you made to the model to support WindMil?
Yes. So there are several changes that we've made to the model to support WindMil. One of the things that you noticed was we added contingent value domains. I don't have time to get into those right now. I would love to talk with people offline about it. But essentially what we've done is there historically have been a lot of transformations that occurred during the extract process or through customizations in order to take your GIS data and to turn it into something that Milsoft can accept. What we have done with ESRI is we have taken the standard ESRI model, we've built additional fields and rules and calculations like those contingent values that you saw, we've actually built those into the utility network model so that you can look at what Milsoft is extracting in your GIS without having to rely on some sort of interpretation to happen to get it out to Milsoft.
Great, Robert. Yeah, thanks for that explanation. Here's another one. What's your roadmap for this tool? Len, you want to handle that one? You've been working with this pretty closely.
Sure, Chris. Yeah, kind of anticipated that a little bit. People would be curious. So right now we're really just wrapping up the low and high fidelity support, making sure that it's good to go. And we think it is. That's why we scheduled the webinar. We're also looking to add some enhancements, some load control points support in that model, along with some just general productivity enhancements about combining files and just, making it easier for the engineer to, again, just take all the roadblocks away. Just let me get going. So that's what we're focused on right now, usability, making it friendly. Our next steps we're really interested in is generating the equipment database directly from the UN or from the extractor. We're excited about that because we think it'll give us the ability to really put out individual equipment information from the utility network. That'll be super useful, we think, for creating really detailed models, individual transformer specs, regulator specs. It should be good for breaker settings. Looking forward for that. And then the next one is trying to crack that load data nut, being able to generate those SLD files, giving people something flexible that they can use to pull their load data from, whether it be AMI or from their SCADA historian, be able to pull that data in, get it into files, get it incorporated into their model with, just a few clicks. That's what we're after.
Great, thanks, Len. Hey, we're running out of time. There was one question about the config file being a simple spreadsheet. Can you show an example? And I guess in the last few seconds that we have, Robert, do you want to hit on that and any other one that you've seen that you want to answer? And then we'll, of course, have written answers to these questions that we couldn't answer today.
Yes. Anyone who's been through one of these projects before knows that the mapping process can seem quite daunting for implementing Milsoft. So what we have is we've taken the process and we've boiled it down to essentially a spreadsheet. There are a number of different tabs down here that allow us to control how that extract happens. So how do we interpret the elements in the utility network model into objects within our Milsoft extract? How we need to extract and interpret different fields from our model into the Milsoft extract. If you have specific values in your model that we need to translate into specific Milsoft model values, we have a tab that allows that. And then there's a couple other tabs here that get more interesting, we'll say, but I don't feel like we need to dive into right now.
Okay, yeah, thanks. And oh, did you have one real quick, Robert? Otherwise we have to go.
I was just there was one other question about the high fidelity model, including poles and structures. We didn't touch on that very much, but yeah, the utility network model also includes structures in your model as participants within the network with a number of different attributes on those. So you can absolutely include structural information in your utility network and use that to drive different studies and life cycles.
Great, thanks. So yeah, just to wrap it up, yeah, thanks Remy for joining us. Thanks Len and Robert for the presentations and demos. And thanks to all of you who have joined this. We really appreciate your participation. Hopefully you got something out of this. We'll post the recording of this so you can share it with friends. And I hope that you have a good rest of the day. Take care.